Okay, so let's finish this problem where we left off. So in all of these cases, they still look like fractions. I wrote them that way, but really 18 divided by 1 is just 18. 4 divided by 1 is just 4. And so these can all be rewritten as just whole numbers, so that all the fractions are now essentially gone from this equation. So we get 18x plus 4 divided by 1 is 4 equals 3 divided by 1, that's just 3x, minus 2 divided by 1, which is just 2. And so you get this more friendly equation that you should find a little bit easier to solve. Right? And so how are we going to solve this equation? Well, we need to get x by itself on one side of the equation. And so we can't have x on both the left and the right hand side, so we need to eliminate it from one of these sides of this equation. And so we will eliminate it from the right hand side. That's usually the typical thing to do. So I'll subtract the 3x from the right hand side to eliminate x from the right hand side, but I'm also forced to do the same thing to the left hand side if I want to get a solution that makes any sense, that actually relates back to the original equation. So again, and the idea is, you know, the thing that we normally say is to keep the equation balanced out, you have to subtract 3x from the left hand side as well. And here I'm going to combine like terms, and what I'll end up with is 15x. The plus 4 just gets copied down. The 3x was eliminated, and then we have a 2 left here, but notice the sign in front of the 2, which has to stay with the 2. So there's a minus sign here, which makes the 2 a negative number, and even though the 3x is gone, the negative sign, the minus sign, is still there. And so what's left over on the right-hand side is negative 2. Right? So the minus sign and the negative sign, they're pretty interchangeable. It's just a matter of context. In the step above, it's a minus sign. Now it's what we would call a negative sign. And then to further get x by itself, we are going to eliminate the plus 4 from the left hand side, and we could do that by subtracting 4 from the left hand side. That'll cancel that out. But to keep the equation balanced out completely, we have to also do the same thing to the right hand side. And again, on the left hand side, when the 4's go away, what remains is the 15x. Right? The 4's are gone. On the right hand side, we combine like terms, negative 2 minus 4, which is negative 6. Right? And continuing on, so at this point it should be pretty routine. If you've been working on some examples and you've looked at the previous examples that we've done, it should be pretty routine. It should have been routine a couple steps ago, actually. So to get rid of the 15, which is being multiplied to the x, we will divide by 15. That cancels that out. So divide by 15 on the left hand side to cancel out that multiplication by 15. But to keep the equation balanced out, we have to divide by 15 on the right-hand side as well. And so the 15s get canceled out, and we are left with just x on the left-hand side, which is exactly what we wanted. On the right-hand side, we'll have negative 6 over 15, right, which we can reduce. And whenever you get a fraction as an answer like we have here, you need to reduce that fraction. You need to look for ways to see if it's possible to reduce. In this case, we can divide out or cancel out a 3, a factor of 3, from the top and from the bottom. So I like to think of it in terms of canceling out a factor of 3 from the top and bottom. It's just the way I was taught. But the proper way of thinking of it is that we're actually dividing out a 3, and this is probably the way I should have spoke about it earlier in the problem, but whatever you're comfortable saying about it is fine. And so we're going to end up getting, when we divide out a 3, instead of negative 6, we'll have a negative 2, right? Negative 6 divided by 3 is negative 2, and 15 divided by 3 is going to be 5. And so our final answer is x equals negative 2/5. All right, so we are done with this problem. All right, I hope you found that helpful, and thank you for watching.